Let us see one more example, second example. जो फर्स्ट प्रॉपर्टीज थे, प्रॉपर्टीज ऑफ राउथ-हर्विट्ज क्राइटेरिया, जिसमें हमारी थर्ड प्रॉपर्टी थी, उसके ऊपर हमने एक एग्जाम्पल देखा है. वी हैव जस्ट सीन अ क्वेश्चन बेस्ड ऑन द थर्ड प्रॉपर्टी ऑफ राउथ-हर्विट्ज टेबल. Let us solve one example by which we can understand the fourth property of the Routh's table. So we have the second example as we are given with a characteristic equation which is s raised to 4 plus 2s cube plus 3s square plus s plus 2 is equal to 0, and again the same question, comment upon the stability of the system. तो हमको फाइंड करना है सिस्टम स्टेबल है या अनस्टेबल है. तो लेट्स स्टार्ट सॉल्विंग. अगेन इट इज नॉट पॉसिबल टू जस्ट सिंपली फाइंड द रूट्स ऑफ द फोर्थ ऑर्डर. दैट्स व्हाई वी नीड टू यूज द राउथ्स टेबल. बिफोर सॉल्विंग एनी क्वेश्चन ऑन राउथ्स टेबल, सबसे पहले चेक कर दो कि जो हमारा फर्स्ट प्रॉपर्टी था, फर्स्ट प्रॉपर्टी टू वेरीफाई द गिवन कैरेक्टरिस्टिक इक्वेशन, इज देयर एनी कोएफिशिएंट ऑफ s which is 0? There is no any coefficient of s which is 0. So first condition satisfied. Second condition, given characteristic equation has all the signs same, either positive or negative, all have the same positive sign. If this two conditions satisfies, now we can proceed for developing the Routh's table. So यहाँ आएगा s raised to 4 s cube. Yes, so coefficient of s raised to 4 is 1. S cube का coefficient है 2. Then we have 3 1, so it is 3. Then we have 1, and at last 2 and 0. So you have to find the next remaining coefficients or the elements. So s square आपको अभी पता चल गया होगा how to find the elements. So 2 into 3 is 6. 6 minus 1 into 1 is 1. So 6 minus 1 is 5. Divide by, start किया था 2 से, तो divide करना पड़ेगा 2 से. So it is 5 by 2. So it is 5 by 2. If you want, I can write here. So it is 2 into 3 minus 1 into 1 upon 2. So you will get the answer 5 by 2. So it is 5 by 2. To find next coefficient, ये आपको छुपाना पड़ेगा 3 and 1. You have to hide this 3 and 1. So it is 2 into 2 is 4. 4 minus 1 into 0 is 0 upon 2. So यहाँ पे 2 ही आएगा. I told you ना, 1 2 3 1 2 2 0. अगर लास्ट में 0 है तो ऊपर का एलिमेंट ही आएगा. So it is 5 by 2 and 2. Again, if you want, I can write this. It is 2 into 2 minus 1 into 0 upon 2. So it will be 2 only. इसका आंसर 2 ही आएगा. 0 आएगा. s raised to 1. Yes. Look here. 5 by 2 into 1. So it is 5 by 2 into 1 minus 2 into 2 is 4. 4 upon 5 by 2. इसका आएगा आंसर. If you solve this, this will be minus 3 by 5. This will be minus 3 by 5. So it is minus 3 by 5. आगे 0 है तो 0 ही आएगा. S raised to 0, the last row. Yes. It is minus 3 by 5 into 2 minus 5 by 2 into 0 upon minus 3 by 5. Since यहाँ पे 0 है तो यही टर्म आएगा. It is 2 only. If you want, you can just solve this. Minus 3 by 5 into 2 minus 5 by 2 into 0 upon minus 3 by 5. ये तो 0 हो गया. So minus 3 by 5 minus 3 by 5. So 2 ही बचा. So it will be 2 only. right? So please write down this table. Yes. Now again, so we have done with this table. So हम क्या करते हैं? We analyze the first column of the Routh's table. Which is the first column? This is the first column of Routh's table. Right? I will write here. Yes. First is +1. पहला क्या है? +1. Then we have +2. Then we have +5/2. Then we have -3/5, and at last we have +2, and at last we have +2. So ये है आपके फर्स्ट कॉलम के एलिमेंट्स, ये है आपके फर्स्ट कॉलम के एलिमेंट्स. Check the fourth point in the properties of Routh's. Check the fourth point. Fourth point, what we have written in the fourth point, the number of time the sign changes in the first column of Routh table indicates that many roots या फिर poles या zeros on the right hand side of S plane. तो जितने बार साइन चेंज हो रहा है उतने पोल्स होंगे राइट हैंड साइड ऑफ S plane. So let us check. +1 to +2, +1 to +2. Is there any sign change? No change. From +2 to +5/2, no sign change, so no change. From +5/2 to -3/5, yes, sign change. Sign change. From +5/2 we are going to -3/5, so sign change हो रहा है. Again, from -3/5 to +2, there is again sign change. Sign change. तो कितने बार साइन चेंज हो रहा है? 2 times. एक बार यहां पे साइन चेंज हो रहा है, एक बार यहां पे साइन चेंज हो रहा है. So the total number of sign changes in the first column indicates the total that many roots are lying on the right hand side of S plane. तो यहां पे 2 बार साइन चेंज हो रहा है, इसका मतलब है 2 poles lie on the right hand side of S plane. So please write down this. So I will write here. Okay. So total number of poles, since question was asked on stability, sir, how come? Because we are given with characteristic equation. Characteristic equation क्या होता है? Denominator होता है, denominator of a transfer function. Denominator gives the information about poles. So that's why I can write total number of poles. What is the highest power of S? It is S raised to 4. So I can write total number of poles is how much? 4. Total number of poles on right hand side of S plane, is equal to, yes, this equals to the total number of sign changes in the first column is equal to total number of sign changes in first column. Yes. कितने बार साइन चेंज हो रहा है इन फर्स्ट कॉलम? 2 times. +5/2 से -3/5 and -3/5 से +2. So 2 times the sign is changing. So I can write how many poles are on the right hand side of S plane. So it is 2 poles. It is 2 poles on right hand side of S plane. Total number of poles on imaginary axis, अभी तक ये मैंने आपको सिखाया नहीं है. In next example, I will discuss about the number of poles on imaginary axis. For time being, write down 0. For time being, write down 0. There are no any poles on imaginary axis. So ये first हो गया, ये second हो गया, ये third हो गया. Write down fourth. Total number of poles on left hand side of S plane total number of poles on left hand side of S plane. Now total number of poles कितने हैं? 4 है. 4 में से 2 तो कौन सी साइड पे है? 2 poles are on the right hand side. 2 poles are on the right hand side. 4 में से 2 गए. There are no poles on imaginary axis. बचे कितने? 2 poles. So that 2 poles should be on left hand side. बचे 2 ही पोल है, so that 2 poles should be on left hand side of S plane. क्वेश्चन क्या पूछा था? Comment upon stability. Comment upon stability. For a given transfer function, please listen here. For a given transfer function, अगर एक भी पोल होगा right hand side पे, system is unstable. I have told you the definition. अगर एक भी पोल होगा आपका right hand side of S plane पे, then the system is unstable. यहाँ पे तो 2 poles है on right hand side of S plane. Hence, the given characteristic equation is of unstable system. So the given characteristic equation is of unstable system. So ये क्या है? It is an unstable system. So I'm going very slow. I'll make sure you can attempt any question on Routh's stability criteria. इसमें 2 cases है. We will study each one by one. बहुत बच्चे यहाँ पे गलती कर देते हैं. What they do, they see there is only one minus sign. सारे पॉजिटिव है, एक ही माइनस साइन है, so one pole on right hand side. नहीं, वो गलत होगा. How many times the sign changes? एक प्लस से माइनस हो रहा है, फर्स्ट चेंज, एक माइनस से प्लस हो रहा है, सेकेंड चेंज. So 2 times the sign is changing, hence 2 poles on the right hand side of the S plane. Yes. So I hope आपको जो मैंने थर्ड और फोर्थ प्रॉपर्टी बताई थी राउथ्स की, इसके ऊपर मैंने 2 एग्जांपल्स लिए थे. सो फ्रॉम दीज 2 एग्जांपल्स वी आर क्लियर विद द थर्ड एंड फोर्थ प्रॉपर्टी ऑफ द राउथ्स. राइट डाउन द फोर्थ प्रॉपर्टी, द फिफ्थ प्रॉपर्टी. Write down the fifth property of Routh. Write down, for the Routh table implementation, please write down the fifth property, the fifth point in properties of Routh table. For Routh table implementation, the coefficients of characteristic equation must be real only. Coefficients of characteristic equation must be real only. In bracket, write down the coefficients cannot be imaginary. The coefficients cannot be imaginary, exponential, sinusoidal. The coefficients cannot be exponential. First is imaginary, exponential, sinusoidal or complex. So what this point says, जो आपका given characteristic equation होगा, it must be real only. It cannot be imaginary, it cannot be complex, it cannot be sinusoidal, it cannot be exponential. Yes, so write down the 6th point. 6th point लिखो, 6th point. Write down, if any power of S is missing, if any power of s is missing, if any power of s is missing in the given characteristic equation, if any power of s is missing in the given characteristic equation, except write in bracket all even or all odd, if any power of s is missing in the given characteristic equation, except in bracket all even or all odd, all even or all odd, represents at least one pole, represents at least one pole to the right hand side of S plane, represents at least one pole, represents at least one pole to the right hand side of S plane. राइट हैंड साइड ऑफ एस प्लेन पे एक पोल तो होगा ही, सिस्टम क्या होगा, विच मेक सिस्टम अनस्टेबल, which will make system unstable, which will make system unstable. Now इस पॉइंट का मीनिंग क्या है, 6 पॉइंट का मीनिंग क्या है, अगर कोई भी s का टर्म मिसिंग नहीं है in the given characteristic equation except all odd or all even, मतलब ऐसा हो सकता है आपका characteristic equation s raised to 4 plus 2s cube plus 1 is equals to 0. Yes, अगर ऐसा होगा then you have to follow the Routh's table. So it is a valid characteristic equation. This is called nothing but all even power of s. All even power of s. अगर ऐसा होगा characteristic equation which have all even power of s, then we have to proceed for the rouths-hurwitz table, right? या फिर आपका होगा s raised to 5 plus 3s cube plus 2s is equals to 0. ये क्या है, all even, all odd. The powers of s are all odd. अगर ऐसा भी होगा equation, then also it is valid. And in order to find the stability, one should proceed with the Routh's table. लेकिन अगर आपके पास होगा if the characteristic equation is something like this, s raised to 5 plus 2s raised to 4 plus 6s square plus 2s plus 1 is equal to 0. Now if you see properly, s cube का term missing है, s raised to 5 है, 4 है, 2 है, there is no any s cube term. So if some s terms are missing, then we can conclude that एक तो pole होगा on the right hand side of s plane, and without solving anything you can say this is unstable system. There is no need to solve, directly you can say it is an unstable system. Why? Because s cube, s की power raised to 3 is missing, right? So ये जो 6th point था उसका meaning ये था. Please write down all these things. Right. So write down the last point in the properties of Routh-hurwitz criteria. Last point 7 point होगा वो हमारा 7 point होगा. Write down if the characteristic equation contains only even power of s, if the characteristic equation CE contains only even power of s, only even power of s, it represents at least one pair of poles on imaginary axis. It represents at least one pair, underline the word pair, P-A-I-R, pair. It represents at least one pair of poles lying on the imaginary axis. So if you have only s in terms of even powers, ऐसा कुछ होगा इक्वेशन, then अगर इसका आप सॉल्व करोगे, इसका at least one pair will lie on the imaginary axis, right? At least one pair of poles, right? One pair of poles will lie on the imaginary axis. मतलब ये j omega है, this is my sigma, this is s is equals to sigma plus j omega, this is my s plane. तो अगर ये कोई इक्वेशन होगा तो एटलीस्ट वी नो कितने होने चाहिए टोटल पोल्स, 4 पोल्स होने चाहिए, लेकिन मिनिमम एक पेयर तो होगा ऑन इमेजिनरी एक्सिस, ऑन इमेजिनरी एक्सिस. राइट, तो दीज वर सम प्रॉपर्टीज ऑफ राउथ-हर्विट्ज क्राइटेरिया. सो आई होप आपको सारे प्रॉपर्टीज क्लियर है. हम क्या करेंगे, हमने फर्स्ट और सेकंड प्रॉपर्टी, सॉरी थर्ड एंड फोर्थ प्रॉपर्टी के ऊपर, यस थर्ड एंड फोर्थ प्रॉपर्टी के ऊपर हमने एग्जांपल्स देखे थे. नाउ रिमेनिंग जो प्रॉपर्टीज है उसके ऊपर भी एग्जांपल देखने हैं हमको, राइट? देन विल गो एंड सॉल्व प्रीवियस ईयर गेट फॉर बोथ ईसी एंड इलेक्ट्रिकल. एंड देन और भी है क्वेश्चंस, डीआरडीओ के क्वेश्चंस है, आईईएस के क्वेश्चंस है. कंट्रोल सिस्टम सब्जेक्ट इज ऑल्सो देयर फॉर सिविल सर्विसेज, राइट? सो उसके भी क्वेश्चंस अगर होंगे इस टॉपिक पे, वी विल ट्राई टू सॉल्व इन द क्लास ओनली. सो दिस वाज द बेसिक आइडिया अबाउट द प्रॉपर्टीज ऑफ राउथ-हर्विट्ज क्राइटेरिया. नाउ जस्ट टेक एन एग्जांपल. Let us take an example. I guess it is example number 3. I have s cube plus 5s square plus 2s plus 6 is equal to 0. Again the same question, comment upon the stability. This is nothing but the characteristic equation, CE लिखो, CE. This is the third example. So CE क्या है? s cube plus 5s square plus 2s plus 6 is equal to 0, and the question is comment upon stability. Comment upon stability. Now yes, अगर कोई क्यूब का इक्वेशन आया है, if you have any cubical equation, characteristic equation, there is no need to draw the Routh's table. There is no need to draw the Routh's table. There is no need to draw a Routh's table. Then how to identify whether it is stable, unstable or margin stable? There is one shortcut trick. एक यहाँ पे trick है to solve these questions. This trick is applicable for any question which is based on cubic, right? थर्ड ऑर्डर सिस्टम के लिए ये एप्लीकेबल है, राइट? नाउ व्हाट टू डू, आई विल राइट दिस एज, इसको मैं ए नाम देता हूं, ए, सॉरी नॉट दिस टंग, जस्ट अ मिनट. एस क्यूब का कोएफिशिएंट 1 है, एस क्यूब का कोएफिशिएंट 1 है, मैं उसको ए नाम देता हूं. एस स्क्वायर का कोएफिशिएंट 5 है, इसको मैं नाम बी देता हूं. S का कोएफिशिएंट 2 है, I'll name it as C and this is my D, right? A, B, C, D. Now what is the trick? Trick is that write down first, if please pay attention, if inner product now if you look at coefficient A, B, C, D, coefficient B and coefficient C are the inner product because वो A और D के अंदर है, so we call it as a inner product. If inner product, what is the inner product? B into C. It is B into C is your inner product. If inner product is greater than outer product, yes, what will be the outer product? Outer product will be A and D. So A into D. If inner product, which is B and C, multiply करना है आपको, is greater than the outer product, which is A into D, then system is stable system. System is stable system. Very simple. No need to find the roots. No need to do the Routh's table. It is only valid for cubic equation, right? Cubic equation. Yes. What is the first thing? अगर inner product, which is B into C, अगर ये product ज़्यादा है as compared to the outer product is A into D, then the system is stable system. Please write down this. Right? ये था first. Second point, please pay attention. If inner product B into C is less than, I'll use some different pen, is less than the outer product A into D, then the system is unstable system. Then the system is unstable system. Yes, ये second point क्या बोलता है? अगर A into D, which is the outer product, A into D is the outer product, अगर वो बड़ा है, if it is greater than the inner product B into C, then the system is unstable system. Please write down, right? And the last point, right? Write down. Third point, if inner product, I'll write IP for inner product. IP मतलब inner product. Inner product मतलब क्या है? B into C. अगर inner product is equal to outer product, what is the outer product? It is A into D. Then the system is, yes, you're right, and the system is marginally stable. Then the system is marginally stable system. Yes. जब हमने चैप्टर चालू किया था, I told you Routh-hurwitz criteria deals with the absolute stability of a system. Absolute stability में क्या आता है? Stable, unstable and marginally stable system. जिसमें in definition of marginally stable, I said if non-repeating poles lie on imaginary axis, then system is marginally stable. तो यहाँ पे भी अगर सिस्टम मार्जिनल स्टेबल है तो उसके पोल्स कहाँ पे होंगे? उसके पोल्स के बारे में भी इंफॉर्मेशन चाहिए, राइट? सो इफ इनर प्रोडक्ट इज इक्वल टू आउटर प्रोडक्ट, द सिस्टम इज सेड टू बी मार्जिनली स्टेबल एंड राइट डाउन the poles will lie on imaginary axis. The poles will lie on imaginary axis. The poles will lie on imaginary axis. उसकी वैल्यू क्या होगी पोल्स की? इस शॉर्टकट ट्रिक से द वैल्यूज ऑफ पोल विल बी S is equal to plus minus under root, it is D upon B J. पोल्स कहां पे होंगे? सिस्टम तो इज मार्जिनली स्टेबल, लेकिन पोल्स कहां होंगे? पोल्स विल बी ऑन इमेजिनरी एक्सिस, लेकिन कहां पे होंगे? द वैल्यू ऑफ D अपॉन B, D क्या है 6, B क्या है 5, तो 6/5, सो प्लस माइनस अंडर रूट 6/5 J, योर पोल्स वहां पे होंगे आपके. सो सिंपल. अगर आपको क्यूबिक इक्वेशन आता है, इफ देयर इज अ क्यूबिक इक्वेशन, straight away you can use this trick method. inner product and outer product multiply करो. अगर inner product बड़ा है system is stable, अगर outer product बड़ा है then system is unstable. अगर दोनों same है then system is marginally stable. Marginally stable और poles कहाँ पे होंगे? Poles will be at S is equals to plus minus J under root D upon B. D upon B is nothing but the coefficients, right? Coefficients होंगे ये. Yes. Now since we know the sorry. Now since we know the trick, can we solve this question by using this trick which I just showed you? Yes, of course you can solve. Yes. First, this is my inner product IP. It is 5 into 2, so it is 5 into 2, which is 10. And my outer product OP, outer product is 1 into 6. 1 into 6 is 6. So my inner product IP is greater than OP. We know this is stable system. This is stable system. अगर आप इसका राउथ टेबल बनाओगे, routh-hurwitz टेबल बनाओगे, you can see there will be no sign change in the first column. अगर चाहिए तो you can just practice, same answer आना चाहिए राउथ टेबल में भी. Right? Very simple logic, very simple logic. याद रखना है आपको ये ट्रिक. Yes, and it is only valid for a cubic equation. Right. Yes. I'll change the question little bit. Right, example number 4 होगा ये. Example number 4 होगा. I'll write CE is equals to. I'll write 2s cube plus 5s square plus 2s plus 6 is equals to 0. Again comment upon stability. Yes, please use the trick method and tell me the answer. क्या आएगा इसका? I hope सबका आंसर अभी तक आ चुका होगा. Yes, inner product IP is what? B into C. 5 into 2 is 10. Outer product OP. Yeah, right, OP. Outer product is A into D. A क्या है? 2 है. 2 into 6 is 12. So it is 12. So OP is greater than IP. System unstable. Right? This is an unstable system.